Hey there, welcome to another college algebra video starring yours truly. This is section 3.6, polynomial and rational inequalities, and as you might have guessed by the name, we're going to learn about solving polynomial inequalities and rational inequalities. No hidden agendas here. And we're also going to talk about what modeling with inequalities might look like, okay, and the type of problems you might see there, okay? So what is a polynomial inequality? It's simply any inequality that has a polynomial in it that can be set compared to 0. Less than 0, greater than 0, whatever. So even if you have x squared plus 3x greater than 9, right? That is still a polynomial inequality because I can subtract 9 from both sides and compare it to 0. All right, and the reason that comparing to 0 is so important is because when you're talking about whether one number is bigger than another one, right, that's one thing. But if you're comparing to 0, I don't need to know even what the number is. I just need to know the sign. I need to know whether I'm positive, that means I'm greater than 0, or whether I'm negative, that means I'm less than 0, okay? And so that gives us that idea of the sign being important, gives us a method that will allow us to kind of always solve these if you follow the step-by-step method, okay? So we're going to look at two types of solutions. We're going to do the algebraic version first. That's the way the book teaches it. I'm also going to show you how to use your calculator, okay, to help out. Just for my students that are watching this, if you're using your calculator, you have to draw a picture on your work of what's on your calculator because I can't see your calculator. So you've got to copy it over so that I can see it. And you can say I used my calculator, that's great, but I've got to see the picture that your calculator gives you so that I know what's going on, okay? That's what I'm expecting to see anyway. So how do we handle this? We solve polynomial inequalities by first comparing to 0, and then we solve the equation if we replace the inequality with an equals. Okay, and these solutions are called boundary points. They have to be real numbers. If you get an imaginary number, they don't count as a boundary point. Okay, and then we draw a number line and we put the boundary points on there. So if we have two boundary points, for example, we have 1, 2, 3 different subintervals, these different groups of numbers. And then what we do is we test a number in each area. We just pick a random number that happens to be inside of each area, not on the endpoints, but somewhere in between. And we test those numbers. Okay, that's step 4. And if you get a positive number for that test point, then you're positive the whole time. And if you get a negative number for that test point, then you're negative the whole time. And the reason for that is that if you're a continuous function, and all polynomials are, and rational functions are continuous except at where the domain has a problem, and we'll use that as a boundary point too, then what you've got is that if you're positive, the only way to get to negative is to go through 0. And our boundary points are exactly where you go through 0. And so that's why we can test just one point in each of those subintervals and get the sign for the whole thing. So we're looking for the signs, and this is actually we're not the Houston Astros, but we're looking for the sign. So we're looking for whether we're positive or negative in each area. This is sometimes called a sign chart, in fact, when we make this on the number line. All right, and I'll show you what it looks like here in just a moment. And then we answer the questions, obviously, once we get the signs. So how does this work? Here's an example. We want x squared minus x greater than 20. We want to solve that. Well, the first step is to compare this to 0. So just like we normally do when we're solving a quadratic equation, a quadratic polynomial, we want to compare it to 0. So we subtract 20 from both sides, we get this. And now we're going to solve x squared minus x minus 20 equal to 0. And this step right here, step 2, involves previous things, right? So just like normal, math builds on itself often, and algebra certainly does. And so we need to remember how to do this from chapter 1. All right, and this does factors into x minus 5x plus 4. And so we get x equals 5 and x equals negative 4. We can't factor and solve up here. There's no 0 product property for inequalities, right? You can't factor and then put each part greater than 0 or something like that. Don't do it that way. You've got to follow my steps. Okay, so you solve the equation. These are our boundary points right here. What do we do with our boundary points? Right? We draw a number line and we put our boundary points on that number line. So we put -4 and 5 on that number line. And now we're going to take a look at the function f of x equal x squared minus x minus 20, and we're going to test, okay? We're going to test numbers. So I'm going to pick a number over here like -5. I'm going to pick a number in between like 0. I'm going to pick a number over here like 7. And I'm going to plug those into my function. So use your calculator to plug it in. I'm not going to do it completely. I'll do the first one, right? If I plug in -5 squared minus -5 minus 20, what do I end up with? I end up with positive 25 plus 5 minus 20. That's 10. Now here's the thing. I don't care that it's 10. I don't care if it's 10 or 110. I care that it's positive. Okay? So if I plug in 0 and I plug in 7, all right, I'm going to get other numbers. Here I get -20. If I plug that in, that's negative. I care that that's negative. All right. If I plug in 7, all right, I think I end up with 22 if I remember right. All right, and that's positive. Again, it doesn't really matter what the number is here. It matters that I get a positive or a negative. Okay, so how does that answer my question then? What's the answer? Well, what did I want? I wanted, let's go back. What did I want? I wanted this, my function, greater than 0. Okay? So what does the answer look like? Well, the answer looks like this. -4, I was positive over here. I was negative up here. I was positive over here. So I take -4, not including it because it's greater than, not greater than or equal to, and I color in this whole side over here because I'm less than -4. Or bigger than 5. All right, and I'll be honest with you guys. I would much rather see it. I don't need to see every single number on there. It doesn't need to be a number line. You can just take this right here and shade it in. And you can take this right here and shade it in. And I'm happy with that. Okay, what's the answer in interval notation? -infinity to -4, union 5 to infinity. That's the, if they ask you for intervals, that's the answer there. Okay, so if this inequality had been less than 0, then I'd take the negative one, right? I'd take the numbers in between. All right, but that's the process for it. So I want you guys to try it yourself. Okay, so here's a second inequality for you to attempt to solve. And so pause the video at this point and take a look at that. 3x plus 4 greater than or equal to x squared, and solve that for me. And then I'll go over with you. Okay, so how are we going to start here? We want to compare it to 0. I'm going to subtract 3x and 4 from both sides just because I want to have the x squared to stay positive. So I get 0 greater than or equal to x squared minus 3x minus 4. Okay, what's the next step? The next step is we set this equal to 0. This solves by factoring also x minus 4, x plus 1. And so x equals 4 and -1. We draw a number line. -1 is over here, 4 is over here, and we're going to pick some test points in between here. Okay, so I put -2 here, 0 here, 5 here. You guys can pick any numbers in between. If you pick a number in between, you can pick 0, 1, 2, 3, anything in between. All right, whatever. And then I'm going to plug these numbers into my original function. My function is this. Here's your f of x. So I'm going to do f of -2, which is -2 squared minus 3 times -2 minus 4. Okay, and that is 4 plus 6 minus 4, which is 6, which is positive. That's all I care about is positive. Right? If I plug in 0, I get 0 squared minus 3 times 0 minus 4. I get -4, which is negative. And if I plug in 5, I get 5 squared minus 3 times 5 minus 4, which is 25 minus 15 minus 4, which is 6 and positive. Okay. You guys have to show me every interval. Okay, you have to show me a test point for every interval because it doesn't always alternate. I know the two problems we've seen, you do plus minus plus or whatever, but that's not always the case. And so because of that, you need to make sure that you test each individual interval, and I need to see those tests. Okay, now the question is, what answers our question, right? What are we looking for? Well, This is backwards written than we're used to. This is 0 greater than or equal to f of x, which means what? F of x is what? Less than or equal to 0. Right? The inequality is pointing towards the f of x, which means I'm looking for negative. So what is my solution set? My solution set is -1 to 4, but this time I'm including the endpoints because it's less than or equal to. All right, I'm including the endpoints. Okay? So that's the process. Rational inequalities are very similar. The solution step is very similar as well. The only difference for rational inequalities, if you're doing the method I just showed you, is in step 2, boundary points also include domain issues, right? So if the fraction equals 0 at -2, you have to include -2 as a boundary point because that's a place where your function is not continuous, and so that's a place where you could change from positive to negative. You kind of disappear on one side and pop out on the other side, okay? So that's the only difference in the step-by-step processes for rational inequalities. But I want to show you a different way to do things, all right? This is using your calculator. So another method, instead of comparing to 0, is to look at the pictures and to let the calculator do some work for you. Now, in solving the boundary points, you've got to do that still in algebraic form. You've got to use your algebra to solve for the boundary points. But other than that, you're using your calculator. So let me show you how this works. Here's a rational inequality. 2x over x plus 1 is greater than or equal to 1. So what we're going to do is we're going to call our first function 2x over x plus 1, and we're going to call our second function just 1, right? So this is our first function, this is our second function, and we're going to plug those in our calculator. Okay, so I've already set it up. Here's my calculator. Here's 2x over x plus 1. Don't forget the parentheses. And here's 1. All right, so if I go to graph it, the blue line is my first function and the red line is my second function. And you'll notice that they cross each other here, okay, and they disappear here. So what are my boundary points? Let's come back. What are my boundary points? My boundary points are two things. First of all, domain issues. Well, the domain here is x plus 1 is not allowed to be 0, so x is not allowed to be -1. So -1 is a boundary point. And then the other thing I have to do is I have to set them equal to each other and solve algebraically. So I multiply both sides by x plus 1. I get 2x equals x plus 1. I subtract x from both sides. I get x equals 1. And so these are my two boundary points, -1 and +1. I draw a number line, -1 and +1. But now what do? Now I go back to the calculator. Okay, here's -1. To the left of -1, which one's higher, the blue or the red? Well, obviously the blue is, right? The blue is bigger than the red. And so if the blue is bigger than the red, let's take a look at our original inequality. Our original inequality was this direction, right? So we're looking at y1 versus y2. So y1 is greater than y2 on this interval, okay? Go back and look. How about between -1 and 1? Between -1 and 1, the blue is below the red, and so we say that that's less than, because y1 is less than y2. And then after 1 again, the blue passed the red again, and they don't ever intersect again, even though it looks like they're leveling out. If they would cross again off the screen, we would have found it algebraically, okay? So that's why it's important to do these first. This is bigger. So which one do I want? I want bigger than, and we want or equal to. And so my solution then is -infinity to -1 union 1 to infinity. Hey, wait. You included the 1, but you didn't include the -1. Why not? Because where did -1 come from? It came from my boundary domain, which meant -1. If you plug in -1, you get a 0 in the bottom. That's never allowed, right? So I can't include -1 whether this is greater than or equal to or not. It doesn't matter, because when -1 gets plugged in, you don't get anything. It doesn't even exist. Okay? So that's how you could use your calculator, and you can use your calculator for the rational ones or the polynomial ones. Again, I'm happy with that process. I want you to know the algebraic process too, but if you're going to use your calculator, you got to draw a good graph and show me what's going on, right? You got to have your calculator here, you got to tell me there's -1 right here, there's +1 right here where they intersect, that kind of thing, okay? But feel free to use your calculator for that. All right, so here's the application of how you might use an inequality. All right, so an object being propelled straight up from ground level with an initial velocity of 80 feet per second has a height that's measured by this. This is the function. This is given to you. I will give this to you. This is not physics class. I don't expect you to memorize these formulas. I'll give it to you. All right, so we want to know how long, what interval of time is the object higher than 64 feet above the ground? Well, that means I want S, the height, greater than 64, or this inequality, -16t squared plus 80t is greater than 64. Okay, that's what I want. So, how do I solve that? Well, I can solve it either way. I can compare it to 0. This has a -16 in common, so I factor that out. I get t squared minus 5t plus 4. And then that factors also t minus 4, t minus 1. And so we have two boundary points, 4 and 1. Create your number line. Here's 1. Here's 4. Remember that if we're talking about time, 0 is actually our lowest number here. It starts at t equals 0, so I can't pick a number like -7. That doesn't make any sense. So I got to pick a number like 1/2. Change the color here. And I'm going to pick a number like 1/2. And then I'll pick a number in here like 3, and then I'll pick a number over here like 5, and I plug it into this equation. And so what ends up happening, I'm going to let you do the evaluation. Okay, I'm going to let you do the evaluation, but here I get a negative sign, a positive sign, and a negative sign. So how does that answer my question? That tells me that the solution set is when? 1 to 4. And so my answer is between 1 second and 4 seconds. In between 1 and 4 is when I'm greater than 64 feet off the ground. All right. So hopefully that helps. And if you have any questions, as always, reach out and let me know. Thanks.